Recording. Okay, so we look at question 1. So question 1, they're saying choose the correct statement on the range of uncertainty, okay, on the two measurements that we've been given there. So the two measurements are 0.150 grams, and then the other one is 0.15 grams. So we have to choose the correct statement, okay, on the range of uncertainty for these two numbers here. Okay, so how do you find the range of uncertainty? I'll just abbreviate it as this. So the range of uncertainty, we find it by subtracting the upper reading, okay, the upper reading minus the lower reading. Okay, so let's find the range of uncertainty for this. So for us to find the range of uncertainty, okay, then we have to find the uncertainty itself. So what did we say? How do we find the uncertainty of a certain measurement? Okay, so we follow the last significant figure. Okay, so in this number here written as 0.150, which one is the last significant figure? This 0 here is significant. Okay, it's significant because it's a trading 0, okay, and there's a presence of a decimal point. So this 0 is significant. So the last significant figure here is here. So when you go back to your abacus, these were we used to call these as the ones, right? And then here, these are the tenths, and then the hundredth, and then the 1,000th here. Okay, so meaning the uncertainty here, okay, the uncertainty here is going to be equals to what? Okay, so it will be 0.001 here. So the place where you have your last significant figure, okay, that's where you're going to have 1. So this is 0.001. So this is the uncertainty here, okay? And then the uncertainty here, it will be in the last significant figure, which is 5. So if these are the ones, okay, these will be the tenths, this will be the hundredth. So it means here, okay, the uncertainty is equals to 0.01. Okay, so now let's find the range of uncertainty here, which will be the upper reading. So the upper reading here will be whatever we have here plus this, okay? So if I add 0.150 plus 0.001, what will be my upper reading? My upper reading will be 0.151. And then my lower reading will be this number subtracted by this. So I'm going to say 0.50 minus 0.001. Okay, so that gives me my lower reading as 0, I mean 0.149. So we can subtract this to find the range of uncertainties for this. Okay, so 0.151 minus 0.149. Okay, so that gives me what? 151 minus 0.149. That gives me it gives me 0.002. Okay, what about the range of uncertainty for this measurement here? That one is going to be the upper reading. I'll write it in blue. The upper reading here will be this guy plus this. So that will give me what? 0.16, right? If I add these two, I'm going to get 0.16 minus. If I subtract 0.15 minus 0.01, I'm going to get 0.14. So here, the difference or the range of uncertainty will be 0.16 minus 0.14. So this gives me a 0.02. Okay, so now we can go back to this question here and check the options. So the first one, they're saying the range of uncertainty in this number is the same as this. So this is false. We see that the range of uncertainty here, they're not the same. This is 0.002, this is 0.02. Okay, so this one can't be the answer. And then B, the range of uncertainty, okay, in 0.150 is more than this. We see that this number here is actually what? Less than this. So it means this option is also false. Okay, and then option C, the range of uncertainty in here is less than here, which is true because this 0.002 is actually less than 0.02. So the correct option here for us was to pick option C. Okay, so any questions on how we found the range of uncertainty there? So I've showed the whole working here, okay, so that you understand where it's coming from. Okay, so now that I've shown the whole working, if you do not want to waste time, okay, just check the uncertainties. The one that has um, the lower uncertainty, okay, it will have a lower range of uncertainty. Then the one with the bigger uncertainty, it will have the bigger range of uncertainty. So this one was 0.01, which is bigger than this 0.001. Okay, so we expect that the range of uncertainty for this should be greater than the range of the uncertainty for this. Okay, so any questions on question 1? Okay, so if you still have problems dealing with that such a question, you can go on my YouTube channel. Okay, just search uncertainty and significant figures. We had a full lesson where we explained how to find the answers to such questions. Okay, so if you're still having problems, use my channel, Tutor Poul Solutions. Anyone can access those videos on YouTube, so they are free. So you should be using that channel. Okay, yeah, it's going to help you learn a lot of things. Okay, so if there are no questions, I'll move to question 2. So I can erase these things. So question 2, what are they saying? So question 2, they're saying which digit is uncertain in this measurement? Okay, that has been written as 360 point nanometers. So this point here is very important, okay? Because we said the uncertainty digit is the last significant figure, okay? So here, because of the presence of this decimal point here, it means this 0 is significant, okay? So the last significant figure is the uncertain what digit. No wonder here we're saying this 0 here is our uncertain digit. Okay, so the answer there should be A. Okay, 0 is the uncertain digit, meaning these 3 and 6, they are what? They are certain digit. Okay, so always take a closer look to the number that you've been given. Okay, so the uncertain digit is always the last significant figure. So if, for example, this number was written as 360 and then nanometers without the point, it means this 0 here is not a significant 0. Why? Because there's no presence of a decimal point and it's a trailing 0. So we discussed all those properties, all those rules when we are beginning. And the videos are there on YouTube. You can watch them. Okay. So if the measurement was represented as this, then this 6 here would be our uncertain digit. Why? Because it's the last significant figure that I can see in this number. Okay. And then the 3 would be the certain digit. So that's how it works. So make sure you revise that, okay, because in the exam it's going to come. All right. So if there are no questions, I'll move to question 3. So question 3, they're saying the moles of iron sulfate given by this formula was determined as 0.1 moles. Determine the number of moles of oxygen atoms that are present in this compound. Okay, so this is the iron sulfate that we've been given here. Okay, so this iron sulfate, the way it is here, okay, we're going to say this is 1 mole. Okay, this is 1 mole of the iron sulfate. So in 1 mole of the iron sulfate, okay, how many moles of oxygen atoms can you see? Okay, so when you say atoms, it means we are counting each element, okay, as an individual element. So here we can see oxygen and a 4 by each side. So it means there are 4 moles, okay, of the oxygen atoms. So now 1 mole of the iron sulfate has 4 moles of what? Oxygen atoms. What about if I have 0.1 moles of this? 0.1 moles of this. Okay, how many moles of oxygen atoms am I going to have? So you just cross multiply here. So x multiplied by this, I get x is equals to the 0.1 multiplied by 4, I get 0.4 moles. So these will be the moles of the oxygen what? Atoms. So be very careful of the questioning. okay, or the particles that they are looking for. Sometimes they can say molecules. Okay, here they said atoms. But when they say molecules, it means here the ratio is going to change. It won't be 1 to 4 if they say atoms. Because, I mean, if they say molecules. Because molecules, it means you have to group them by 2 by 2. Okay, so if they said molecules here, our mole ratio would have been 1 mole to 2 moles. Because this 4 divided by 2 is just 2. So make sure you take note of the particle that they are asking you here. So here they said atoms, so just take it direct. So the answer here is B, which is 0.4 moles, okay, of oxygen atoms. Okay, so I'll just be moving. Whenever you have a question, just ask. And then question 4, which digit is certain in this measurement here? Okay, so most people get this question wrong. Okay, we said for us to identify a certain digit, we first have to identify the uncertain digit. So this number has been written as 300 nanometers, right? Okay, so the uncertain digit is the last significant figure that you can see in a number. So here we only see one significant figure, this one here. So it means this figure here is uncertain. Okay, it's uncertain because it's the last significant what figure. And then these 2 zeros are not significant because they are trading zeros and there's no decimal point. So we are going to say this number has no certain digit because the 3 that it has, it's uncertain. And then these ones here cannot be considered because they are not significant. Okay, so here the answer, the best one was D, where we're saying none of the above choices, So there is no certain digit here. There's just an uncertain digit, which is 3. Okay, question 5. How many electrons are in an isotope that has been written as this? So we have X to the power 3 plus, and then 52, and then 24. So we said that always the bigger number is what we call as the mass number. Okay, the bigger number is what we call as the mass number. And then the smaller number here is what we call as the proton number. So meaning number of protons, right? So the mass number here, okay, the mass number is the summation of the particles that are found in the nucleus. So in the nucleus, you're going to find the protons plus the neutrons. So this 52 that you can see here is a result as adding the number of protons plus the neutrons. Okay, and then in a neutral atom, okay, if it does not have any charge, like this charge here, in a neutral atom, the number of protons, okay, will always be equal to the number of electrons. Okay, right. So those are that is the important information that you have to know. And then here they're saying how many electrons are in this here. Okay, so it means that in the neutral atom, okay, before it had this charge, the number of protons and electrons were equal. So in the beginning, before it had this charge of 3 plus, the number of electrons were what? 24. And then now the charge has moved, okay, from 0, it has become 3 plus. What does that mean? It means this atom lost electrons, okay? It means it lost electrons. So the balance between the negative charges and the positive charges was disturbed. No wonder here we're having what? A 3 plus, okay? So if 3 electrons were lost, then how many have remained? So it means 24 minus what? 3. So this one is just going to give you 21. So it means how many electrons do we have here? Okay, we just have 21 electrons. So the answer there should be A. Okay, so any questions there? Okay, so if there are no questions, we move to question 6. So how many neutrons are in this same thing? Okay, neutrons, we just say subtract the mass number 52 minus the proton number 24. So this will be, on my calculator, 52 minus 24, that is 28. So you go on your options, we pick our 28. So 28 is the answer. Okay, and then question 7. They're saying how many protons are here. So for the protons, you don't even have to do anything. Just look at the proton number here, which is 24. So we're going to pick that one. Okay, as simple as that. We go to question 8. Question 8, they're saying the solution dilution formula is given as M1 multiplied by V1 is equals to M2 multiplied by what? V2. So before we even answer the question, let us state what these things here mean. So the M1 is the concentration before you dilute, okay, or before you add water to that solution. And then the volume, the V1 is the volume before the dilution. M2, okay, is the concentration, okay, M2 is the concentration after the dilution, meaning after you add water. And then V2 is the volume after you add water. So I'm going to give a very practical example, right? So if this is your cup here, and then in this cup you have tea, and then you put a lot of sugar, okay? This tea is going to be very sweet when you drink it, okay? And then let's say you dilute it now. You dilute it, you put some water, okay? And then you have this tea again. So once you put water to this tea that was very sweet, what do you expect to happen to it? Okay, it becomes less sweet, right? Okay, so that becoming less sweet, it means the concentration of sugar has reduced. Okay, so here the concentration of sugar was very high. And then once you add your water here, it dilutes. So the concentration of the sugar reduces. So it means that tea now will be a bit sweeter. Okay, it will be less sweeter than it was before, right? Okay, so what has happened there? It means when you're diluting, the concentration, okay, before diluting is always greater or more than the concentration after diluting. Okay, so this M1 here, which is the concentration, is always greater than M2. Okay, so now when you go on our options, we see that M1 is always more than M2. So this is the answer here. That's the correct statement. Okay, and then here they're saying M1 is always less. This one is false. Okay, because it can't work like that. And then C, M1 is always equal to M2. This is not true. And then even option D there is not true. So the only correct option here is what? Option A, which is that the concentration before dilution is always more than the concentration after what? After dilution. Okay. So now, um, do we have any questions here on question 8? Do you have any questions there? Okay, so if there are no questions, I'll proceed to question 9. So question 9, they're saying what? They're saying, what does the letter M represent in the dilution formula? Okay, so we said this M is just the concentration. Okay, but this concentration will be in moles. So the concentration in moles has a special type of name, which we call as molarity. Okay, so M represents molarity, which is the concentration in moles. Okay, so here we're going to pick C as our best option. Okay, and then question 10, they're saying which parameter remains unchanged during dilution of solutions. Okay, this one we all know, it's just the moles. So the moles are always constant during dilutions. Okay, and then the volume, the concentrations, they change. Okay, we look at question 9 now. So question 9, question 11, I mean. So question 11, they're saying percentage yield is applicable to, okay, option A, they're saying reactants and products. Option B, reactants only. Option C, products only. Option D, none of the above choices. Okay, so the answer here is product only. So when you're finding the percentage yield, okay, you are interested in how much of something you're going to produce from the solution, from the reaction that you have. Okay, let's say we have reactant A plus reactant B, and then you want to produce maybe product C. Okay, so the percentage yield will be only applicable to what you're producing here and never to the reactants. Okay, so here the correct option, we're going to pick C. It's only applied to the product. Okay, and then question 12, okay, what is the oxidation number of oxygen in O3? So on the rules, okay, when I was explaining, when we had class, I said the oxidation number of a pure element, if it's not combined to anything apart from itself, okay, the oxidation number is always 0. Okay, the oxidation number is always 0. As long as that element is not combined with anything, okay, then the oxidation number is what? Is 0. Okay, so here we're going to pick A as our what? As our best answer. Because this one here is not combined to anything, it's just combined to itself. So the oxidation number is 0. Okay. And then question 13, they're saying which particle is used to balance charges in half reactions. Okay. So here we know the particle that is used is just what? Electrons. Okay. It's just electrons that is used to balance half reaction. So half reactions, we're going to have an example as we solve the other questions. You're going to see it. But the particle that we use to balance is just what? Electrons. Okay. So next, we look at question 14. So we are still on oxidation numbers. Okay. What is the oxidation number? Okay. What is the oxidation number of Hg in this ion here? Okay. What is the oxidation number of Hg in this ion? So this ion is Hg. So Hg is mercury. And then it has a positive 2 charge. And then we have two of these things here. Okay. So we said the overall charge here, which is the power, is always a combination of the individual oxidation numbers of these compounds that you are combining. Okay, so here we have 2 mercury. Okay, we have Hg plus Hg. Okay, these ones should give you 2, which is positive 2, this charge here. So when I add them to just be 2 Hg is equals to 2. So meaning the oxidation number of Hg, okay, the oxidation number of Hg will just be plus 1. So plus 1, 1 plus 1 is going to give me 2. So the oxidation number of this mercury here is just going to be what? Plus 1. So we are going to pick A as our best option here. Okay, so that is the answer there. Do we have anyone who has questions? Okay, so if there are no questions, we'll move to question 15. So question 15, they're saying, what is the molarity of the nitrate ions in 16.4 milliliters of 0.24 0 molar copper nitrate solution? Okay, so here we first have to get the mole ratio from the balanced chemical equation. Okay, so this one here, it shows that we have 1 copper, even there we have 1 copper, and then we have 2 of the NO3. But here we can only see 1. So we have to balance this guy by writing a 2 in front there. Okay, so now this equation is balanced. So the mole ratio, okay, of the copper nitrate solution, this one, to the nitrate ions, which are these ones, is just what? 1 to 2. Okay, so here we've been given the volume and the concentration of the copper nitrate solution. So we can use it to find the moles. Okay, so we know that the moles is equals to the molarity, which is the concentration, multiplied by the volume. So now this volume here always has to be in liters. Okay, so we're going to say my M is 0.240 multiplied by the volume is 16.4, which is in milliliters, right? So we change it to liters by dividing by what? 1,000, like this. So this will be equals to, so let's do that. So we have 0.24 multiplied by, okay, 16.4 divided by 1,000. Okay, so what does that give me? Okay, what does that give me? Let me do it. So I have 16.4. Okay, 16.4 divided by 1,000. So that would be the volume in liters, right? And then multiplied by 0.240. Okay, so that one will give me 0.003,936. So these here will be the moles for the copper nitrate. Okay, so if I have 1 mole of copper nitrate, I have 2 moles of the nitrate ions. What if I have this guy here, which is 0.003,936? Okay, here I have X. So I'm going to cross multiply. So my X will be equals to 2 multiplied by this guy. So multiplied by 2, what am I going to get? Okay, what am I going to get? Okay, I'm getting 0.0 0.07872. Okay, and I cannot see it here. Okay, so let's pass through the calculations. Maybe we made a mistake somewhere. Okay, so here they're saying what is the molarity of the nitrate ions, right? And then we've been given the volume, okay, and the molarity of the copper nitrate. So the copper nitrate is this guy here. So this copper nitrate, we dissolve it in water. It's going to dissociate into its um, ions. Okay, so we have the copper 2 plus here ions and the nitrate ions here. But I said you always have to work with a balanced chemical equation. Okay, you always have to work with the balanced chemical equation. So okay, so I see where I made the mistake here. So here they're saying what is the molarity? So me, I read this as moles. No wonder I was calculating the moles. So I'm sure there's no answer here. Okay, so they just want the molarity. Okay, so if they want the molarity, then there's no need to calculate the moles here. Okay, there's no need to calculate the moles. So we just use the mole ratio there. Okay, so the mole ratio is, okay, from this one, if I have one copper nitrate, okay, then I'm going to have what? Two nitrate ions there. Okay, so if this copper has 0.240 molar, okay, then what will be for the nitrate ions? Then you just cross multiply. So this will be X is equals to this multiplied by this, I get 0.48 molar. Okay, so the answer there should be C. Okay, so always be careful when reading. You see that me, I read this as I had moles in my mind. So I was calculating the moles. Okay. But it's they are saying molarity here. So molarity is just this one. So sometimes, okay, they can ask you to calculate the moles. So if they ask you to calculate the moles, you use the approach that I used there. Okay, use the approach that I used there. Okay, and then are there any questions here before we move to question 16?
If this guy was to change the program, go underscore just
okay, so if there are no questions, I'll move to question 16. So 16, they're saying an analyst, okay, was asked to determine the concentration of calcium carbonate in 0.125 grams of chalk. She placed the chalk in a 250 milliliter conical flask and added 50 mils of 0.2 molar hydrochloric acid. The excess hydrochloric acid was titrated with 32.12 milliliters of 0.25 molar sodium hydroxide. Which one is the analyte in this analysis? Okay, so the analyte, okay, is the substance that we are trying to find the concentration for. Okay, the analyte is the substance that we are trying to find the concentration for. So here they are saying determine the concentration of the calcium carbonate. So the analyte here, okay, and they like repeating this question, is this calcium carbonate. But can we see it here on the options that have been given? No, we can't see it. So we're going to say none of the above. That would be a correct choice. Okay, and then it's the same question here, but here they're saying which one is the sample? Okay, so the sample is the thing that contains the analyte. So this calcium carbonate, which is the analyte, it is contained in what? In chalk. So chalk is the sample. Okay, the analyte we said was the calcium what? Carbonate. And then sometimes, okay, they can ask you for the standard solution. Okay, standard solution. So the standard solution, it is the solution whose concentration is known. So in this case, we would have two standard solutions because the concentration of hydrochloric acid is known and also the concentration of sodium hydroxide is known. So that those can be the other questions that he can ask you in such a question. But the sample is the thing that contains the analyte. So the chalk is the sample. The analyte is the calcium carbonate. And then when they ask you for the standard solution, you're going to say the hydrochloric acid and the sodium hydroxide. Okay, so I don't know if there are any questions there. Okay, so if there are no questions, I'll move to question 18, where they're saying how many atoms of oxygen are in 1 mole of sulfur dioxide. Okay, so here we just have to know the Avogadro's constant. So the Avogadro's constant says 1 mole of anything has how many more has how many molecules? Okay, it has 6.022 times 10 to the power 23 molecules. Okay, so 1 mole of anything that you can get, 1 mole of yourself, you will contain these molecules. 1 mole of your friend, they will contain these molecules. 1 mole of your shoes, they will contain these molecules. Okay, 1 mole of anything is going to contain 6.022 times 10 to the power what? 23 molecules. So now here I have sulfur dioxide, right? So this sulfur dioxide is a molecule. So in 1 mole of this sulfur dioxide, how many oxygen atoms can I see? Okay, I can see 2 atoms of oxygen. Okay, so that would be the ratio that we are going to use. Okay, because here they just said 1 mole of this, it means it has this number of molecules. Okay, and then on itself, the sulfur dioxide is just 1 mole. Okay, I mean, it's just 1 molecule. So 1 molecule of the sulfur dioxide, the way it is, it has 2 atoms of what? Of oxygen. Okay, it has 2 atoms of the oxygen there. So meaning that I'll get a cross product here. So I'll say now, what if I have 6.022 times 10 to the power 23 molecules of this sulfur dioxide? How many atoms of oxygen am I going to have? So you cross multiply, it will just be x is equals to 2 multiplied by this. Okay, so 2 multiplied by this, I'll get 1.204 times 10 to the power 24. Okay, so that will be the answer that I get. So these now here will be the atoms of what? Of oxygen. So we go on our options, we select the answer that looks like this. So that will be option C there. Okay, so the one who was answering this paper got the questions correct, right? Because I'm noticing whatever answers I'm finding are already ticked. Okay, so you must be very brilliant. Okay, so let's look at question 19 now. Okay, let's look at question 19. So question 19, what are they saying? So let me erase this. Okay, so question 19, they're saying choose the correct statement about isotopes. Guys, even a grade 12 can answer this one. In fact, a grade 10, because we learn isotopes in grade 10, right? So we know that isotopes, okay, are atoms of the same element that have different what? Number of neutrons. So as a result of having different number of neutrons, it means they will have different mass numbers. Okay, so this one that says but different atomic numbers, no. Okay, atoms the same element but different number of protons, no. Okay, so the only correct option is just this B here. Okay, they are atoms of the same element but they have different mass numbers. Why? Because they have different number of what? Neutrons. Okay, so we're going to pick B there. And then let's look at the last question. Okay, let's look at the last question, which is question 20 from section A. Okay, they're saying a solution was prepared by mixing 0.164 moles of alcohol and 0.623 moles of water. And then they're saying determine the mole fraction of alcohol. Okay, so mole fraction of alcohol is equals to, so here we have 2 solutions, the alcohol and the water. Okay, since we are finding the mole fraction of the alcohol, it's going to be the moles of the alcohol in the numerator here, okay, divided by the moles of the alcohol plus the moles of the water. So this is the formula that we are going to find. So if they asked you to find the mole fraction of the water, then you would have put water on top here. Okay. So we're just going to say X here is equals to the moles of the alcohol are 0.164 divided by the same moles plus the moles of water, which is 0.623. So let's punch this onto the calculator. What are we going to get? So the sum down there to be 0.164 plus 0.623. So that gives me 0.7, 0. What? 0.787. Okay, and then we divide those two. What are we going to have? Okay, am I going to have an answer here? So I have, okay, I have 0.164 divided by 0.787. Okay, so I'm finding 0.208386277. But I round this off to three significant figures. It's going to be 0.208, like this. Okay, so that is the answer. You just come here, you pick A. Okay, so we are done with the section A. So anyone who has a question from section A? Okay, so we are done with section A. So if you'd like to access the full video where we're revising the hottest one, okay, meaning you also get to see the videos for section B, which has 3 questions. Okay, these are the questions. You are free to register with us on our website, and then you'll find the full videos. Okay, so when you go on our website, okay, you will see something like this. So once you register for a course, okay, there's going to be enrolled there at the corner like that. Okay, so that was chemistry. So if, for example, you want to register for chemistry, there's a video in the link in the description below. So you can watch that video to know how you can register, and then you'll get access on our website. Okay, so when now you have registered, you can come and open this course here, which is chemistry. Okay, once you open the course, there are 2 folders. Okay, there's this folder for those who are doing second semester APEC. Okay, but these are just first semester videos, what we are from doing. So you go in general chemistry. Okay, and then in this general chemistry, you're going to find the 5 folders. So here where we have lessons and tutorials, okay, you can open it. We can check what is there. So here we have videos on all the topics that you're going to learn, from introduction to chemistry, all the way up to nuclear chemistry. Okay, we've got lessons on them. Okay, so when you open each of these folders, there are lessons there. There are also summarized notes that you can read at your own. So you can learn at your own pace, okay, at your own time, anywhere, even in your blankets, even if you're at your boyfriend's place, you can still learn. Okay, so these are the videos on all the lessons. You can see whatever you're going to learn in chemistry, the videos are here already, okay, for you to learn at your own time. And then the goodness is that on our mobile app, okay, you can find the link to download our mobile app just in the description. On our mobile app, you can actually download all these videos, and then you'll be watching them offline. Okay, even without the internet, you can still watch them at your boyfriend's house. Okay, so this is the lessons and tutorials video folder. Okay, so that's what is there. So now we also have this folder here for handwritten summarized notes. You can check it out. And then for the tutorials, tutorial sheets, assignment, you come to this folder. Okay, so when you open this folder, you'll find the folder for your university. Okay, so for example, here I'll just pick Apex. You open the folder for your university, which is Apex. Okay, let's wait for it to load. Okay, so once it loads, you see something like this. So we have organized the videos on the tutorial sheet and assignment based on the intakes. Okay, so the latest intake is 2025 January intake. Okay, so when you open this one here, the 2025 January intake, you're going to find the videos for all the tutorial sheets, okay, that you have had so far. So you can see here, even the assignment, it was there. There's written solutions and video for the assignment. And then for the tutorial sheets, their videos. You can see from tutorial sheet 1 all the way to tutorial sheet 5. So tutorial sheet 6, which I know is going to be on atomic structure, we're also going to solve it and upload it here. So you can watch it anytime. Okay, so these are the tutorial sheet for this semester. But if you want, okay, you can also try to check out the videos for last semester, okay? Especially that you haven't yet received the tutorial sheet on atomic structure. So you can go in the 25 January intake, okay? You go there, you're going to find the videos for all the tutorial sheets that that intake has. So it has from tutorial sheet 1, you can see even the assignments there, all the way to tutorial sheet 13. So these videos are there. You can watch them and learn at your own time, at your own pace. So like for atomic structure, you can see atomic structure last semester had 3 tutorial sheets. There's this one, tutorial sheet 6, tutorial sheet 7, tutorial sheet 8. So you can watch any of them, okay, on the tutorial sheets. Okay, so that's how you can access the tutorial sheets. Okay, and then what if you want some past papers? Okay, if you want some past papers, you can still go to general chemistry here. Okay, and then just come to the past paper section there. Okay, and then you're going to find different universities. Okay, if you don't see your university here, just go in this folder where it's written our past papers. Okay, but for this one, I'm going to choose Apex. So when you go in the Apex folder for the our past papers, we have some written solutions and videos. So you'll be interested in the videos. So you go to the videos. Okay. Once you reach here, you're going to find all these past papers that have been solved. Test 1, test 2, quiz 1, quiz 2, the final exam papers, they are all here solved for you, waiting for you to what? To watch. So it's a very good platform to use, okay, discretelearning.com, so that you can learn at your own pace at your own what? Time. Okay. So I don't know what's wrong with you guys. You don't want to subscribe, and as well, you don't want to watch the videos that are free. Like we post free videos on our YouTube channel. So you can go to Tutor Post Solutions channel. It's on YouTube. And here I just post free videos for everyone. Okay, here you don't have to subscribe. So there are a lot of videos here. So make use of this channel. Okay, if you know a friend who is struggling with math, with chemistry, okay, whatever subject in your pre-med, make sure you invite them to this channel because there are a lot of videos here that can help you pass easily. So we explain the concepts, okay? Whatever troubles you, we've already explained it before. So make sure to use this channel here. It has a lot of videos. So you just search for whatever you want, okay? You can say, maybe you can say um maybe redox reactions or oxidation numbers, and then you put tutor post solutions at the end. The videos are going to come, you're going to watch. So make use of this YouTube channel. It has free videos for everyone. Okay, so that is it. Okay, and then for those who need more materials, we have a paid up feature where you can access all these that you can see, the past papers, the tutorial sheets, the topic videos, and it's not only chemistry, okay, even math, even biology, even physics. So all the 4 NS courses or pre-med courses, we have them here. Right, so thank you so much for watching this video.